Hi everyone, and welcome to our tutorial on conducting a cyclic voltammogram in the glovebox. CVs can give you great qualitative and quantitative information about your catalysts and other small molecules, and while straightforward to do, doing them in a glovebox is a bit cumbersome. Before you get started, you should read the SOP for how to do a CV in our glovebox. It'll give you some details that the video may leave out. But by the end of the video, you'll have the practical knowledge to do a CV on your own. Okay, so to get started, the first thing you're going to want to do is prepare your electrolyte solution. You'll likely be using TBAF or tetrabutyl ammonium hexafluorophosphate. Other electrolytes exist, but that's the main one we're using right now. You want at least a 0.1 molar solution. So normally you're going to be using 5 mils of solution at a time. So just calculate the proper mass of TBAF ahead of time before you start. And it's also good to mention that here we don't have a proper scale. So normally we weigh by displacement, but here I'm just kind of being cavalier with it and doing an approximate weighing off of the scale, just so I don't get everything messy because it's all. Okay, so now we're going to get the solvent to dissolve our electrolyte solution in, and there are a bunch of different solvents you can use, and depending on the glove box you might be more limited. Here we're able to use acetonitrile, but if you're in a more strict glove box, then you might be restricted to THF instead. To take an accurate volume of the solvent, we use a syringe here. Make sure there's going to be 2 syringes, one that will be used for the dissolved electrolyte solution and one just for the solvent. Make sure at this point you just use the syringe that's labeled with the correct solvent, in this case ACN for acetonitrile. And as I'm getting everything ready, just make sure that you have the correct vial and everything. As you can see me putting a vial down and then picking it up and putting another one down because I got mixed up. So make sure to label everything. That'll help keep everything organized, especially when working in a small box like this. So here you can see me getting the syringe for the acetonitrile and taking up 5 milliliters at a time. We have 5 ml syringes in this glove box, but if you use the different one, you might have different size syringes, so just be mindful of that. Here I said we're going to make a 10 ml stock of our electrolyte solution, but I'm actually going to take up 15 milliliters here. So I'm going to do this 3 times. And the reason for that is I want 5 milliliters of just solvent for a washing solution. So I'm going to pipette 15 or use the syringe to suck up 15 mils and put it in a wash bottle, and then take 10 of that and put it into our electrolyte solution. So you might think it was unnecessary to put the 15 mils in one vial and then go back and transfer 10 of that to the electrolyte again. But the only reason I did this is because normally I have to use a regular glass pipette to pipette everything out, and it's since it's not very exact, I just put it all into one vial anyway, and then the remainder is for the wash. So here it wasn't necessary, but when your solvent bottle for the stock solvent is too low to use the syringe, you're going to have to do that anyway. Okay, now that you've added the solvent to your electrolyte, you can give it a swirl a few times just to help it dissolve, and then it's a good idea to label everything at this point because you've got several vials now and it's really easy to get confused, and you don't want to accidentally use the wrong solution here. Something else I want to note here is that once you start to get acetonitrile and you have vials with acetonitrile in it, if you're not using them, you should keep them capped because acetonitrile can poison or does poison your glovebox catalyst, and you want to minimize how much acetonitrile vapor goes into the glovebox atmosphere because of that. Now I know it's a little hard to see here, but what I'm doing is I am taking our 3 electrodes, and the 3 are a counter, a working, and a reference electrode. The counter electrode is that graphite rod. The working electrode is the one that has that Teflon jacket, and then the reference is just going to be a silver wire there. And what I'm doing is trying to get a vial, find my wash vial, and put all 3 of them in there, give it a few swirls to clean off any debris that might be on the electrodes before we start using it for our solution. All right, so at this point here, I've removed the working electrode, and what I'm doing off screen is drying it a bit. And what I also did is prep the polishing pad. So the polishing pad we use is it's essentially a felt pad that we can add alumina to, and it creates just enough abrasion to get any possible corrosion or debris off of the graphite or the glassy carbon part of the working electrode. And you have to polish the working electrode in a figure 8 pattern to evenly polish it. That I will talk more in depth in the SOP for this. But once you do it for maybe 30 seconds, it should be good to go. Okay, and that is it for the polishing. So we only need to polish the working electrode, and I've just done that. And I have already rinsed the other 2 electrodes with some of our solvent, so they're good to go. So we can start attaching those to the alligator clips right now, like I'm showing in the video. And while I do that, I'll just quickly go over the next few steps in our procedure. So the next thing we're going to do is we're ready to take a CV. So we need to take a CV of just the electrolyte solution first to make sure that everything is working correctly and make sure that our solution is actually not contaminated. And it will be very obvious from the initial CV. So once you're done with your first CV of just the electrolyte solution, you're going to want to do another CV of the electrolyte solution, but this time you're going to add in some of your internal standard. In most cases, it's going to be ferrocene. After ferrocene, then you take another CV, and then you're ready to start taking CVs of your target complex, and then you can do additions of your substrate, and then anything else you want to work on. So that's going to be another video, so stay tuned for that, and I'll go more in detail there with what the next steps are. So thanks for watching.